Alright, so today we're learning the super important second derivative test. And then we'll talk about linear approximation. So here's second derivative test right here. If you know that you have a critical point, that's what that means. You're given a critical point. If f double prime is positive, is that concave up or down, by the way? So if it's concave up, you're going to have a minimum. This should make sense. If I draw something that's concave up, where we have critical point there, which means that we have a horizontal tangent. So there's a horizontal tangent right here, and it's concave up. That's the minimum. So that's all the second derivative test says is. Just a different way to do it. So same thing for if it was negative, which means it's concave down. What does concave down look like? Upside down U. Again, you're being told that there is a horizontal tangent and concave down that's going to be a relative max. Alright, this only happens in super certain situations. So the first two problems are awesome because those are super certain situations, and then I haven't really looked at the rest of the worksheets. I don't know if they're good or not. So using the graph of f double prime below, that's important. This is f double prime. What is happening at f of 1 when f prime of x equals 0 at 1? So that just really says that at f prime of 1 will equal 0, which means that what's going on at 1? It is a critical number, you all said? Very good. It is a critical number. So what's going on? We're given f double prime. So here's 1. Is this positive or negative?
Negative.
It's negative. So f double prime is less than 0. That's concave what? Concave down. At 1. It's concave down. At 1, the derivative is equal to 0. What does that mean? There's a relative what? The relative max at x equals 1 because, and here's your justification for it. F prime of 1 equals 0, and f double prime of 1 is less than 0. Could you instead say it's concave down at 1? You could. I don't really care. But again, I'm trying to do the bare minimum for you. If you don't like notation because it scares you, you're like, I'm not going to remember that. You could also just say it's concave down. Okay, again, we really would not use this test. We really wouldn't use this test unless we're forced to. So, like in this number 1, do I know enough about f prime of 1 to know if it's increasing or decreasing? No, I don't know enough about f prime before 1, after 1. So we have to use the second derivative test. Alright, number 2. So we have a function where f of 3 is equal to 8, f prime of 3 is equal to 0, f double prime of 3 is equal to negative 4. Determine if it is a minimum or a maximum. Justify your answer. Try this one on your own, or at least think about it on your own. I'll give you 30 seconds. I'm calling a random person. And Neil, she was like, no. Not me. Nathan, what'd you get for this one?
There is a relative max x equals 3 because f prime 3 is 0 and f double prime of 3 is less than 0.
That was beautiful. Beautiful. Relative max at... How much work did you need to do before this? 0 work. Usually that's how these problems work. Because f prime of 3 is equal to 0, and f double prime of 3 is less than 0. I can write is negative. I don't really care. I'll just write is negative to be different. Just different ways to do the same thing. Don't be thinking like, why is this problem do it this way? They're the same thing. These are the same. All right. We might just do number 3 and be done. We're just gonna do number 3 and be done, and then not be done, like done. We have another little thing to learn too. Okay, so we'll just do number 3. We'll kind of leave 4 by itself. It's like the same exact problem. So we're given the second derivative, and we know this information right here. Determine if f of x has a relative max, min, or neither. We haven't talked about neither. So we've only talked about if f double prime is positive or if f double prime is negative. If f double prime equals 0, it's inconclusive. There is no neither. It's inconclusive. So this problem is really stupid because there is no such thing as a neither using second derivative test. It's either it is, it isn't, or you can't tell. Doesn't mean it's neither. So let's go ahead and go on. So what are my x values that I care about? Negative 2, 2, and 0. Well, what is f double prime of 0? Does it tell me? So I need to do a smidgen of math. Let's do that little teeny eensy weensy bit of math. What's f double prime of 0? Negative 4. Hey, let's do all these for all my critical points. What's f double prime of negative 2? 8. What's f double prime of 2? 8. So we're going to have a relative max where? Just x equals 0? Because f prime of 0 equals 0, and f double prime of 0 is negative. That's all you need. Like, I don't know if you can see this. Like, this is her key. Look at how much writing that is. You do not need to do that much writing. It's a lot of writing. We don't do that. I don't do writing. I don't care. I'm here to do the bare minimum with you. Alright, and we have a relative min where? Plus or minus 2. Because f prime of plus or minus 2 is equal to 0, and f double prime plus or minus 2 is positive. That's it.
Please like and subscribe.
No, we have like a little more sections to do here. Yeah. Well, I'm going to read the explanation from the notes key. I don't know who made this notes key, so I'm not really directly. Alright, this is the explanation for number 1. So look at your explanation for number 1 and then theirs. If f prime is 0, f prime of x equal to 0, and it is a turning point at x equals 1, we also know that it is concave down at this point because the second derivative is negative. So it must look like this. Therefore, there's relative maximum. That's too much. Right, Jonah? That's too much writing. You just want to write less, right, Jonah? It was a long sentence. Hey, let's go to linear approximation. Okay. Yeah.
So if f prime is 0, then we know that the maximum and then we find if it's positive or
If the second derivative is positive or negative. Yeah. If the second derivative equals 0, it's a dumb question. That's all I'm going to go with. Okay. Linear approximations. This kind of looks a little confusing. I'm just going to try to bring some light to you. Okay, so let's play pretend. Who's ready to play pretend? None of you. Great. Fantastic. So here's some function. I just drew some function. Okay? And I give you the point right there. And this is some ugly function, all right? Looks just like Neelish. It's terrible looking. You do not... Hey, I got to get all this out of the way before Wednesday, because I don't think I can say that.
What if like someone just says like pull up any video?
Yeah, no, none of you are gonna do that. Actually, I did the same thing at my other school. Don't worry, you're not alone. I rip on everyone all the time. So then before I got hired, I made the mistake of telling Mr. Deuce, like, oh, I make video notes, so you can just watch my video notes and see what kind of teacher I am. So I was like, oh, no. I'm like, well, do you know what? Maybe he'll watch one where I didn't insult anybody. And he must not have. Or if he did, he's probably cool with it. So I'm just going to stick with it. Okay, so sometimes it's really hard to find what the value of this purple point is. So you don't want to, like, if the function was like square root of ln of x, you don't want to find out where that purple point is. You can't plug that in. That's terrible. That's awful. So what you can do is, it's called linear approximation. You can find the derivative at the red point, say what that line is, because we can do that. And then, because it's easier to plug values into a line. Do you agree? Much easier to plug them into a line than like the square root of ln of x to whatever is going on. Then we can get the value of the blue point. Well, the value of the blue point is pretty gosh darn close to the purple point. That's kind of what we're doing. Now, in this case, is blue point an overestimate or underestimate? It's an overestimate. Do you know why? Because it's above the other one. Technically, do you know why? It's right here. If the function's concave up, it's going to be an underestimate. This one I drew right here is concave down. So if the function's concave down, it's going to be an overestimate. You do need to know this. And if you're totally lost on it, like, I don't memorize this stuff. I just understand it. I just do a quick drawing. Right? Because if I'm totally lost, if I'm like, oh no, is this an overestimate or underestimate? Okay, well, it's concave up. And any tangent line I draw is always below. So it must be an underestimate. Okay? Let's put this to some use. So, of course, our first example is a function where you really could approximate something. So, whatever. So here's a function. It gives us the first derivative. That's nice. Not a lot of work needs to be done here. So let's go ahead and answer this question. Write the equation of a line tangent to the graph at this point 1, -5. And we know what the first derivative is. Okay? So it's going to be y minus y1 equals slope x minus x1. Alright, I haven't told you anything you don't already know? Okay, let's plug in what we do know right now. Do I know y1? -5, so I'm going to say plus 5 equals, do I know the slope yet? I'll get there in a second. X minus 1. How do I find slope? Plug in 1 into the what? Derivative. They already gave us the derivative. How nice of them was that? So what? Plug in a 1. What do I get? -9. Boom. I just did part A. Now, we're going to use this line to estimate the value of f of 1.1. All we do is we take this 1.1 and plug it into x. Sometimes they'll give us the y value. They'll say, oh, estimate the value of x given y is whatever. Okay? So we're going to do y plus 5 equals -9, 1.1 minus 1. What is 1.1 minus 1? It's 0.1. What is -9 times 0.1? -0.9. They usually don't give you numbers that are really that tough. It's kind of what they do here. And then, what does y equal? Subtract 5, and you're going to get -5.9. So I'm going to put these little squiggles for estimates. So we're estimating it. Do I have enough information to know if this is an underestimate or overestimate? Why do I not have enough information? We don't know what? We don't know the actual function. So we don't know the concavity. So we don't know enough about the second derivative. So that's the approximation. If you wanted to plug in a 1.1 into here, it's going to be gosh darn pretty close to this right here. Do you want to do that or just move on? Do it. So if I were to clear everything, and then I would just type this in, so it'd be 3 times 1.1. Watch this not work on the video, and then calculus is broken. Calculus is broken. Do I need to take the exam? So, yeah, not a very good estimate, but an estimate nonetheless. There's a reason we don't really use linear approximations. And the reason why the estimate isn't very good is because our slope is huge. Look at that slope. It's a negative 9. So going from one point to the next, the slope is about a difference of 9. So is the approximation going to be accurate here? Heck no. Slope is huge. Alright, let's move on. Alright. We don't need to do all these notes. We just need just enough of them. Determine if the estimation, I just kind of just did that. If it's greater than or less than the actual value. We don't know the second derivative, but I think they wanted you to plug it in. We just kind of did that, so let's ignore that.
Wait, how do you just
Justifying the answer would be concave up, underestimate. Concave down, overestimate. Those are the only words I'd ever use.
So concave up equals underestimate, like that's it?
Yeah, actually I can go through it. So when I said that we don't know enough information, actually I kind of lied. Don't we know the second derivative? If I'm given the first derivative is 3x squared minus 12x, it's 6x minus 12. Very good, Neelish. I hate how this problem's on 2 different pages. Otherwise, I probably would have not complained about it. All right. So now I care about the answer at 1, right? So let's find f double prime at 1. And it's negative 6, which is concave up or down? Concave down. So is this an overestimate or underestimate? If you're totally lost, draw it. Pick any point you want. Is that line completely above or below? It's above. So this is an overestimate. So overestimate because concave down. That's all you need. Don't overdo it, Jonah. Don't overdo it. Bare minimum. Right, Neelish? Bare minimum. Okay. How much more of this do we need? Because this is like it. Alright, we'll do 6. Alright, 6 is a little bit of a review too, because it talks a bit about implicit, which we struggled with as a class. Don't worry, I'll come back to that at an appropriate time, which is now. Okay, so given dy dx, what does dy dx mean? It's your first derivative. So write the equation of a line at the point 1, 0. So I know I have 1 minus 0 equals some slope x minus 1. How can I find the slope? Plug it in. So dy dx of 1, 0 is equal to e to the 0, 3 times 1 squared minus 6 times 1. What is e to the 0? 1. What is 3 times 1 squared? 3 minus 6. What do I get? Negative 3. That's my equation of a line tangent. Now, on your questions you're going to get, like in your review and on your test, they're never going to ask you, unless it's like a free response. They're never going to go like step by step by step. They're literally going to go right to B. Approximate, use the tangent line to approximate f of 1.2. Just kind of be aware of that. They're not going to walk you through it. But hey, let's use this to approximate. So I know it's y equals negative 3. Plug in a 1.2. What is 1.2 minus 1? 0.2. What is negative 3 times 0.2? Negative 0.6. Okay. Use implicit differentiation. Oh, I think they're doing this so we can find out this is an overestimate or underestimate. So let's go ahead and find the second derivative. So this is implicit. Okay, so I have a function times a function. So right there, right off the bat, this is going to be a chain rule. What's the derivative first? E to the y, tag it, dy dx. 3x squared minus 6x stays the same because it's product rule, plus e to the y. What's the derivative of the second? 6x minus 6. I can simplify this a little bit. What's this dy dx equal? Doesn't equal this right here. So if I plug that in right there, don't I have two of these 3x squared minus 6x's? Don't I have two of these e to the y's? So isn't this e to the 2y 3x squared minus 6x squared plus e to the y 6x minus 6? I mean, that's as much as I really need to do for right now. Alright, so use this to determine if the approximation is either more or less at 1.2. Now, we don't want to plug in 1.2 because that's our approximation. We always want to plug in what we're approximating from. We're approximating from 1, 0. So let's plug in a 1, 0 into this second derivative right here. Want me to plug it in or just tell you what it is? Okay, so we want to go through the math? Alright, you people. E to the 2 times 0, 3 times 1 squared minus 6 times 1 all squared plus e to the 0, 6 times 1 minus 6. Nine? 9? What does that tell us? Underestimate because? Concave up. I think we have a table for the last problem. Want to look at it? Alright, we don't have to do it. It's up to you. Your call. Yes? Can I go through it real quick then? Alright, looking through this right here. It says second derivative is negative, and we're just going from negative 2 to 2. I'm just looking at the clock. I want you to have more time to work on stuff than hear me talk. So I'm going to go through this really quickly. So write the equation line at when x is equal to 1. So I'm looking at this guy right up here. So I'm going to get y plus 5 equals negative 3x minus 1. Okay? Let's approximate 1.1. So it's 1 plus 5 equals negative 3, 1.1 minus 1, which is going to be equal to negative 5.3. Okay, so is this an overestimate or underestimate? So it says that we're concave down. And no worries, he's got to read the whole part of the problem. I'm going through this so fast, it's kind of easy miss. So it's concave down. So again, if you're totally lost, like, because I don't memorize this stuff, trust me. I do as little memorizing in my life as I can. I'm not that smart. So if it's concave down, and I draw any line, I'm always overestimating. So it's an overestimate because concave down. So you know. Hey, that wasn't that long.
Like, subscribe for more content.
Actually, don't. I might get in trouble.